Hello everyone and welcome back to my channel. Today my topic of discussion is overview of adrenal gland. We will discuss adrenal gland further details, but today our topic is very simple and we will take the general overview of adrenal gland. So what happens in case of adrenal gland? First of all, start from hypothalamus. In the hypothalamus, the paraventricular nucleus is present, and through the hypothalamus pituitary adrenal axis or HPA, the paraventricular nucleus releases corticotropic releasing hormone which acts upon corticotroph cell, and these will further secrete alpha MSH and ACTH and other hormones also, but we will discuss about ACTH only today. The ACTH will go through the blood vessel and it will act upon adrenal cortex. So these layers are of adrenal cortex. Okay, the outer layer is zona glomerulosa, then next zona fasciculata, then next zona reticularis. The zona glomerulosa is releasing the mineral part or mineralocorticoids, mainly aldosterone. The zona fasciculata releases glucocorticoids, mainly cortisol, and the zona reticularis mainly secrete gonadocorticoids or androgens, which are generally weak androgens. And the adrenal medulla part generally releases epinephrine and norepinephrine, and which helps to increase the blood pressure, glycogenolysis, gluconeogenesis, lipolysis, etc. In case of zona glomerulosa, the not only ACTH but also angiotensin II, the low level of sodium in blood, high level of potassium in blood, or the hyponatremia and hyperkalemia. This is called what? Hyponatremia, and this is hyperkalemia. This condition will help to secrete ACTH, secrete zona glomerulosa hormone or mineralocorticoids. Angiotensin what does? Angiotensin 2 generally increase blood pressure, and sodium potassium balance will maintains the mineral parts. Now we will take a general overview of these hormones. First of all, mineralocorticoids, MC. The main hormone is aldosterone. It acts upon kidney, especially the nephron, and in the nephron it acts upon DCT and calcium duct. What it does? It creates sodium channel, potassium channel, sodium potassium ATPase pump. This type of channels they creates. And what happens? Potassium is generally secreted out from the blood, and sodium is taken up by the blood, and through sodium water is also taken up. This what it does? This increases the blood volume and increases the blood pressure, and also create the hypernatremic condition or increased sodium. And whenever sodium increases, water is also increased. Sodium potassium ATPase pump also created. Next, the glucocorticoids. In case of glucocorticoids, we will discuss about only cortisol. Cortisol, in case of WBC, it creates the suppressed immune system. In case of muscle fiber and muscles, it catabolizes the protein and diffuse out the protein, and generally it break down the protein to amino acid, and which will further go to liver and convert it into glucose. Then lipolysis. In case of adipose tissue, the lipid is also break down, and the lipid will go to break down into two parts. One is glycerol and fatty acid, and the glycerol part will go to liver and it is converted into glucose. So what happens in liver? There gluconeogenesis occur. In case of gluconeogenesis, amino acid to glucose, and glycerol to glucose. Conversion is done. Then in case of gonadocorticoids, what happens here? They are releases of androgens, weak androgens. And in case of male body, it creates testosterone, and in case of female body, it secretes estrogen. And it also helps to increase the libido effect or sexual desire. We have also described the androgens or gonadocorticoids very deep in the previous video. You can also check it there. Now, how the cortisol level increase or decrease ACTH and cortisol level? If the cortisol level is increased, in case of negative feedback, this will signal hypothalamus to stop the secretion of CRH or corticotropic releasing hormone, which will further stimulate the anterior pituitary to secrete less amount of ACTH, which will further stimulate the zona fasciculata layer of adrenal cortex to release less amount of cortisol. If the cortisol level is down or low in blood, in case of negative feedback, it will stimulate the CRH to increase its quantity, and ACTH will further be increased to anterior pituitary, and then zona fasciculata layer will secrete cortisol. Thus, the cortisol level is balanced. Cortisol is also called stress hormone. And epinephrine, norepinephrine, in case of this, the flight and fright condition. This is between autonomous and somatic nervous system, and this will discuss in further videos. And if we summarize, in hypothalamus, paraventricular nucleus, we secrete CRH, which will go to hypothalamus pituitary adrenal axis. This will act on corticotropic cell, which will release ACTH. ACTH through blood flow, and in case of zona glomerulosa, mineralocorticoids, fasciculata, glucocorticoids, reticularis, gonadocorticoids. And in case of adrenal medulla, epinephrine, norepinephrine. What they does? Increased BP, glucogenolysis, gluconeogenesis, lipolysis. Aldosterone, what does? It generally maintains sodium, potassium, ionic balance, and blood pressure and blood volume. And cortisol, it is stress hormone which suppresses immune system, protein catabolism, lipid metabolism, and gluconeogenesis. Androgen, in case of male, testosterone; in case of female, estrogen, which will affect on libido and secondary sexual character. In case of cortisol, which is stress hormone, and negative feedback mechanism, CRH is decreased, ACTH is also decreased, so cortisol is also decreased. When the cortisol is decreased in the blood, the negative feedback mechanism will help in increase CRH, which will further increase ACTH, which will further increase cortisol. So this is for now. Do like, share and subscribe to my channel, and suggest me in which topic you want the next video. And I think I have cleared all the concept. If you have any doubt or any query, comment down in the comment section. I will try to reply. Thank you.